Hey folks, thanks for joining on today's stream. I hope so you are doing fine and you can introduce yourself in the chat section. We have awesome speakers lined up and you can chat down about your thing. Like you can share your introduction, how you're excited about this session. And those who are new to the stream, we are a community basically, an open source community basically which supports different open source projects and we are trying to basically share on how you can start with those projects as a maybe as a project or if you want if you how you can contribute to those projects side by side. And if you didn't know about the last streams, we did two streams, 2 to 3 streams. Our opening ceremony is with our junior developer advocate with DigitalOcean. Then we have Devrel from sto.io where basically he talks about open source in general. Then we have founder and CEO of HopSpot.io, you can see yesterday. And today we have an awesome guy. I really admire his work. I'm from my starting with open source thing. I get into TensorFlow where I contributed to WebAssembly part on the kernel side. Then inspired from that, so one of my mentor also involved in this project. And from that, I get to know about WasmEdge and basically about second state community side by line. So I'm really excited to bring you here the founder of secondstate.io and WasmEdge project, Michael Yuan. Hi, Michael. Thanks for joining. Thanks for joining our stream. Yeah.
Hi, Katriki. Thank you for having me. Yeah.
Yeah, so there's a kind of a ritual of my stream actually. Is like I always ask what's your definition about open source. So if you can add something like what's your take on open source in a general form, like from your perspective? Yeah.
Oh, yeah. So, well, there is no official definition of open source, right? Is that there's a couple of software licenses. I started my open source career very early on. That's it's almost 20 years ago. So we did one of the first Java application servers, open source Java application servers called JBoss, and then we sold to Red Hat. And during that time, there was really no business model for open source at the time. People are just contributing on their free time. And then the business model emerged. There's things like service and support, which Red Hat was known for. And then you have SaaS and open core models, business models where you have the core infrastructure is open source, but then the service or the commercial layer is more closed. So I think that's pretty much is the predominant form of open source today. Is that the infrastructure is open source, and but I also thought it's very interestingly, there's a new notion of open source in the AI space where people are talking about open source models, which is very interesting in this way because what they're doing is that they publish those models, but on those models, the compiled artifact as we know it, that's right. So in my opinion, unless you publish the whole thing that leads to the models, it can't really be saying. If you just publish models, the same as you publish in the compiled software itself, it's not necessarily really open source. But that's the opinion differs. Obviously, there's debate in this area. So, and I'm very excited to be in this new era of open source, that's the term is being redefined by, say, the publication of the language models and things like that. So, we'd love to, have a more debate and more engagement in the community. Yeah.
Yeah, so like yesterday only, I have a friend, like we both are interested in ML as usual, and we are talking about how like Llama actually opens like Llama, you can say, or LangChain in general. Like this open source models is coming. Like firstly, it's like generally open source project. Now it's open source models of machine learning models, and it basically fascinates many people who want to get into maybe fine tune from their perspective how they can fine tune that particular model and use it in maybe in their terms. So that's always motivating me, like how open source has a wide variety of the wide variety, not only the part of like you have to do just maybe the part of coding. If you just know, you can do something related to machine learning and kind of a contribution at the end of the day. So I didn't take much. I didn't take much time of yours. yeah, I guess we can start off. Maybe if you want to share your screen, and I can add on. Yeah.
Yeah, thank you. Yeah, that's just to add on what you have said. I think it's absolutely right. The core tenet of open source is the ability to modify and then use it on your own. In that regard, the large language model do meet that requirement because, like you said, you can fine tune it, or you can add database to it, like the REG approach, like you talked about LangChain, right? Yeah, that's which leads to my talk, which is how do you, as individuals, how do you actually deploy and use open source models? Especially large language models, as we all know, those models are very expensive to train and perhaps consume a lot of computing capabilities. But what I'd like to show you today really is that how you can do it on your own computer as well, on your laptop, which is what I'm going to demonstrate in a couple of minutes. Is that I have a very normal, regular MacBook, because when I bought the MacBook, large language model hasn't been around. So I thought I don't really need the powerful computer because I just need to get on the internet. But now now I have to run large language model on it. Can I do it? That's do we have the software stack that is not bloated, that doesn't take gigabytes over gigabytes of disk space and memory space. That's something that I'd love to.
Also, like side by side, that's what I'm saying. Hugging Face make it more democratized, maybe to make it ML more maybe to accessible to all, I guess, because people think we have to do so much there. We have to understand neural networks and we have to train on these kind of things. But maybe I guess some of the companies, open source company, at the end of the day, they are doing this thing to make it more, I guess, democratized. Like everyone can use it ML in a regular basis, maybe in some day.
Yeah, definitely. The Hugging Face is the new GitHub, right? It's GitHub is for open source code, but Hugging Face is more for lack of a better word, open source models. Again, I would say it's open source in spirit, because if you look at Llama models, it doesn't meet the classic definition of open source. It has restrictions of who can use it and who cannot, and it's published. What is published is really not the source code; it's the model itself, right? So yeah, that's But yeah, let me start with sharing my screen. Let me see if it's successful or not.
Sure.
Okay, it requires me to give permission. Okay. So can you see my screen? It should be the whole.
It is not till now.
Okay.
I didn't.
Let me try it again. Or maybe I should do the Chrome tab. Okay. Can you see the Chrome tab at WasmEdge runtime? Yeah.
Yeah, I got it. Yeah.
Okay, great. Yeah. So I'll start to say this is if you're interested, this is my project. I started this project. I was a maintainer on this project, but you can see there are a lot more contributors, and we'd love to have your contribution as well. What it does is that this is a WebAssembly runtime, and it's part of the Linux Foundation and the CNCF. So it's we started and we donated to the community, right? So if you so as you know, the CNCF, the Cloud Native Computing Foundation, was built on top of the idea of containerization, containers and the cloud native stuff. So the whole idea of cloud computing has evolved over time. So when AWS first started, it was all about virtual machines. So you have EC2, things like that. You start a virtual machine and then you have your computing load in it. When Docker comes along a couple of years later, people find a more lightweight or a better or easier way to run computing loads using containers. So you do not necessarily need a virtual machine that is very heavy, that consumes a lot of resources. You can have a lightweight way of doing that, which is a Docker and Containerd and things like that. So the whole idea of cloud native and Kubernetes and all that was born with the idea of using container to run applications, right? But I think we are at close to the end of the container cycle as well, because in the end of last year, I think December 2022, CNCF put out a survey for all their members and to survey about the what's coming up, right? So the survey, over 1,000 respondents. That's a lot of most practitioners, people working in the space, right? And the key results, there's only just one key result. That's so it's really the headline result is container is the new normal. So meaning that container is not widely used. WebAssembly is the future. So what follows container is WebAssembly. So what is WebAssembly? WebAssembly is a new virtualization format. Well, it's not really new, but it's a even lighter virtualization format than containers. So it has certain trade-offs, because it doesn't really run Linux, but it runs applications that's written with C++, Rust, Go, Python, JavaScript, and all that. So it supports a variety of different languages and allows those applications to be compiled to very small application bytecode and then run it in secure sandboxes in the cloud. So what WebAssembly brings us is a highly efficient execution environment, highly efficient and highly secure execution environment, and also because it supports multiple languages and multiple platforms, so it provides a wide range of portability that goes beyond what container can bring us. So, for instance, especially in the AI world, if you have a Docker container application, it typically does not. It would not be able to move from, say, even different CPU architectures. So it can't say if the container was built for x86, you can't run it on the Mac or ARM processor, and that's the CPU difference, and the GPU difference is even wider. So in general, a container has to be built for a specific platform and run on a specific platform. But WebAssembly is different. It's more like Java. You build an application and compile the application, and then you will be able to take the application without any change on any device, on a lot of devices WebAssembly supports. So that allows us, for instance, in the AI world, to build an application on my Mac and deploy it on a cloud device that has an NVIDIA GPU. So I don't necessarily need to have an NVIDIA GPU locally because those are expensive things, right? So I could build it on my own laptop using using Mac or using Linux, using only the CPU. But then the result is an application called WASM, and then you take the WASM to an NVIDIA device. It would automatically be able to run the GPU. So it brings benefits like that. So WasmEdge is one of those. It's a leading WebAssembly runtime. And if you are interested, there's lots of contributors. And if you are interested, you can go to the GitHub repository. It's WasmEdge, and you can start it. There's lots of issues that you can go through. Some of them are beginner ready. We have labeled them. So if you are interested, you can go through them, right? So that's, without further ado, I want to show you. Start the presentation by showing you some examples. How do we run, say, large language model applications using WasmEdge, right? So let me try to share my my console. So just hold on one second and share screen, window. Okay, which one? Okay, it's this one.
By the way, Vivian is here. She's saying hi. Yeah.
Hi. So do you see my?
I didn't see till now.
Okay, let me try to share it again.
Sure.
It's okay. It wants to have permission again, but I did give it permission. So let me.
There is nothing from my side. I guess you have access to that.
Maybe I'll share the whole screen. Is that better? That's okay.
That can be better.
No, I think I may have to restart Chrome in order to do that. Is that okay? That's because it seems doesn't give me the it tell me to restart in order to get the permission. Can I do that? Yeah.
I guess I have access. Like I have given access to you that for the same. Can you try again if possible?
Yeah, it says I need to restart Chrome. Okay, is that?
No worries, no worries. Till then, I can take care of the audience. Then, yeah, no worries. Then.
Okay. Let me
Sure.
real quick. Yeah.
Yeah. Thanks, Anshuman, for joining. Yeah. Yeah. Hey, Vinayak. Thanks, folks, for joining, and we are starting off. Till then, till then, those who are joined new, I just give you a brief what actually Michael did. Basically, obviously, we know when we train the models around it, or when we go on the production side on the models, we know it takes a lot of binary stuff to work on. But converting what WasmEdge is doing, it is using technology of WebAssembly, and how it does actually it convert the part. It can directly convert that thing into binary, like directly without any conversion between one scripting language kind of thing. So it totally helps because it is in the binary form only. So it is better like when we run on the system or anywhere, or when in the production also, or when we are creating containers around it. So it's easy for them to do it. So and then I guess Michael is here. Yeah.
Yeah. Now I'm back, and I apologize for that. And let me see if I can.
I'm guessing you can share now, maybe. Yeah.
So
Okay. Cool.
does it work this way? Okay. Yeah, it works, right? Okay. So let me clear this. And so what I'm gonna show you is the local directory, and you can see there are a couple files here. So there's those files are the large language models. So say there's a Llama 2 13B, Llama 2 7 billion. So those are large files. They are multi-gigabytes. The original files are even bigger. Because we have used a technique called quantizing. Those files. Turning the floating point to fixed points. So that reduces their size by significant amount. That's something that's you can look up, right? So there's the Mistral model as well. So those, but still, those models are pretty big. Those are 9 gigabytes, 4 gigabytes, 5 gigabytes, and things like that. And then you have, I have already compiled those WASM files. Those are Rust applications I compiled to WASM. I can show you, after we've done this demo, that's the Rust source code for that, right? So you can see those applications are much, much smaller. This is 3.5 megabytes and 2 megabytes. So it's in the range of megabytes. And I think one of the things that to really pay attention here is that the WASM file is all you need to run those AI applications. There's no other external dependency. There's no dependency on Python. If you think about the dependency for PyTorch, that PyTorch has a dependency of over 3 gigabytes of dependencies. The other Python packages, right? So it doesn't have all those gigabytes and gigabytes of dependencies. It only have 2 megabytes self-contained and cross-platform runtime binary. I can copy it, not just on this machine, because this WASM file is not built on this machine. It's built by the GitHub CI. So GitHub has those GitHub Actions, those Linux machines. They build those WASM files, and I simply downloaded them onto my Mac, and now I expect them to work. I will be able to just copy them to say an edge device like Linux running a router or Linux running a car, something like that. I would also expect them to work. So this is a completely self-contained AI inference application that's written in WASM. So now we use a command line to run this. So of course you would have WasmEdge installed. To install WasmEdge is really easy. Just one line of command. That's and then you say I want to load this model in this particular case. I'll show you how, that we load the 7 billion parameter model, which if you recall, it's about 5 gigabytes in size. And then I want to run on one of the WASM applications, right? The WASM application with the, let me show you what the WASM application does. So if I do that, because I turned on logging, so it would turn on the logging in terms of what's what's in the model, the layers, that's the tensor and all that. So it gives all kinds of debugging information that's about the model. So then the application stops here, pauses here, it asks a question, because it's designed to chat, right? So I would ask a simple question: where is the capital of Japan? Okay, and what it does is that it shows to go to inference, and the result come back instantly, right? So in fact, it generates results in 28 tokens per second. A token is about half a word. So it's faster than the human can type, right? So, and it gives the correct answer. The capital of Japan is Tokyo. So, then let me ask another question, just to show you it can follow the conversation, right? Because now I say, how about India? I didn't ask you what's the capital of India. I just asked, how about India? It should know that given the context, given the question I asked before, it should be able to tell that how about India means how about the capital of India. So it answers the capital of India is New Delhi, right? So it's then I can ask it somewhat related question. Is New York City the capital of the United States? That's certainly the most famous city in the States, right? So it's no, the capital of the United States is Washington D.C., right? So so you can see this this model performs, I think, at a very reasonable speed on my I wouldn't really say it's low end, but it's lowest configuration of a MacBook that you can find on the internet, right? So it's so it is with a 2 megabyte WASM file that's used and running it with WasmEdge, right? So I think the reason I want to demonstrate it is because I think this is by far the easiest way to run large language models. You can see a lot of large language models that are coming out almost every day. People have fine-tuned the Llama model, and they're publishing them on a daily basis. But if you use WasmEdge and the simple function like this, a simple WASM file like this, you'll be able to run it on your Windows machine, on your Mac machine, on your Linux machine, on your edge devices, just anywhere, just any computer that you have access to. Of course, some of them are going to be slow, some of them are going to be fast. Say if you have a device, say if you have a Raspberry Pi, it's going to run pretty slow, but I would still guess it could do 2-3 tokens per second, something like that. It still would be, you wouldn't need to wait for an hour to get an answer. You wait for minutes to get an answer. Here we will wait for, you almost get the answer instantly, right? So this is one of the examples. What I'm gonna do is I'm gonna show you the code behind the example, so that you can. Let me see if I can do this. Stop screen and start to share my Chrome. Why is that it doesn't let me? Oh, it's because I don't have the Chrome tab open. So hold on 1 second. Let me go open that Chrome tab. Okay, let me come back and share. So here is the entire application I've just shown you. So you have seen a WASM application, right? So how do we get to that WASM application to do the things that I've just shown? The application itself is written in Rust. We're going to talk about in a minute. That's why we are not using Python but using Rust, right? But Rust has a reputation of the good reputation is the next generation. It's the language that follows Go. It's one of the most well-liked and well-respected programming languages out there, right? But the negative reputation is it's hard to learn. What I want to show you here is it's not hard to learn. It's the whole application is 66 lines of code with all the boilerplate. So you can see the first function is easy. It's just reading the line from the command. You remember it asked me a question. I type in something and then it give answer, right? So that's it's down here. It's read from the standard input. So there's nothing special here. Then the main function has basically the main function has a couple lines. It loads the model from the command line because I gave the model file in the command line. So it detects that, it loads the model. And then it asks the first question. It gives a system prompt. If you have used ChatGPT, there's something called a system prompt to prime the model, to tell what your role is, so that you can answer questions based on that role. So here we tell the model, you are respectful assistant, right? You want, please answer as short as possible. So that's why it answers in very concise answers. It doesn't veer off to say, the capital of Japan is Tokyo, and Tokyo is what, right? It just tell you the capital of Japan is Tokyo. And then we ask an initial question. The reason we ask the initial question is that we load that forces the program to load the entire model and into the memory, so that it can be served faster in the next question, right? So so all those are boilerplates. That's the prompt, the initial question. And what's really important is really those lines in the loop, right? So basically, when it prints out the question and reads the line and wait for the user input. If the user hit a return, it reads the line, and then it assembles that into what we call a chat template. The chat template is something that comes with the Llama 2 model. It tells you how the Llama 2 model is being trained to follow conversations. It's the training data has a very specific format. It differentiates its questions and answers. So for questions, they are included in the inst tag. It's called instructions, and the answer is outside of those tags. So in order for us to make the model follow the conversation, we have to do the same thing. We have to do the inst to put the questions inside the inst, and then to have the answers, outside of it. So we have to. So in a long question and answer session, we have to do the to assemble the user input and the model output into those chat templates. This chat template is going to vary from model to model. So some model gonna have this the square bracket and inst, and some model gonna have the 3 sign user, 3 sign followed by assistant, to differentiate what user said, what assistant said, right? And once you have that, once you assemble the template, this is essentially string manipulation. You can just turn that into a tensor and then send it to the model, that you have initiated outside of the loop. That's in the main function, right? And then the model does its magic. It runs on, like I said, it's the same WASM file, depending on where it's installed, would be able to dispatch to, say, the GPU, the NPU, the TPU, whatever the AI accelerator that you may or may not have, and use the most advanced accelerators that are available on your hardware to do the AI inference. And the result of AI inference is another byte array, is another tensor, where you can turn turn that into a string and feedback to the user, right? So it's a really straightforward process. And if you I imagine if you don't, even if you don't know Rust, if you have never touched Rust before, you may not be able to write this, but you will be able to read it. You will be able to see, oh, okay, here's what it does, and then you will be able to modify it, right? So a new model comes in, you want to use a new model, but it has different prompt templates. You will be able to know how to modify those two sentences, those two lines of code, to make it so that it's, instead of have square bracket inst, you would have some other delimiters that would fit your model, right? So this really is the whole application that allows you to to do AI inference. So before we go to the slides and explain some the details of the application, let me show you another project which is in the same repository. It's called the API server. The API server is a more complex piece of software. Actually, let me show you its README. Maybe that's easier. So what it does, so here's the 4 instructions how to build it from source code from Rust. But again, because it's cross-platform, so you can download the WASM file directly from GitHub and then run it. When you run it, it's let me see where. Yeah, so here's how you run it, right? You just say WasmEdge server, and there's a couple parameters that you can take. It's what it does is it starts a server with that model. The server has a JSON interface that is compatible with OpenAI. That allows you to use any OpenAI compatible tools like LangChain or like Chat UI and like the chatbot UI. And there's hundreds of projects out there that are OpenAI compatible, right? You just need to put the OpenAI URL and the API key in them, and they're gonna work. You can use the same tools with your locally deployed open source model, or fine-tuned Llama 2 model, right? By just giving so you can select a prompt template, you can give the model, that's so you can do. Sorry, yeah, it's this command, right? So you can specify the model file in the command line, and then tell it, what the template looks like. That's so you would be able to, run this model and start a OpenAI compatible API server entirely in WASM. Because WASM is, like I said, WASM is a container format, or it's a sandbox format. So it works with Kubernetes, Docker, and Podman, Containerd, CRON, and all those tools, so that you can run a WasmEdge application as a container application in a Kubernetes pod, right? So that allows you to take this server and integrate it fully into your cloud native infrastructure, right? So that's so those are that's that'd be the OpenAI compatible server. Now you can test this server. Once you start this server, once you use this command to start the server, that's give it the name of the model, the model file, and the template name. Meaning that's how do I assemble my chat template, and then start this WASM file. It would say it's listening on the local port, and then now you can test it, right? The way you test it is that you can use curl to send the request to the local server that's running. Sorry, I think there's a little bit mistake. This is 8080, so you can test it on port 8080. And so for instance, here, we're just, this is the OpenAI API endpoint. So if you access the api.openai.com, V1 models, it would tell you the available models. And here, because we only have one model, because the server only runs one model at a time, right? So it would tell you what model is running. And then you can use the OpenAI's V1 chat completions API. So here you post a JSON message that basically says, the system message is you are helpful assistant. The user message is who is Robert Oppenheimer, and the model template is selects the model as Llama 2 chat. What it does is it's gonna send you back the message. Robert Oppenheimer is blah 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 blah. It takes Notice that I didn't say answer as precise, as concise as possible, so it gives a long answer, right? And once you have once you have that answer, in the next question you can append it to say role assistant content, this content that's being fed back to you, and then you can ask the next question, right? But if you don't want to do it by hand, you have a lot of tools to do that for you. So for instance, LangChain does it very well. That's they would be able to help you manage this back and forth API calls to assemble those messages into a JSON format that's compatible with OpenAI. And because our server is compatible with OpenAI, you will be able to do it. You will be able to make it work directly with tools like LangChain and the chatbot UI. So those are the two, I would think, interesting little projects that could you get started with your own use of with your own use of the large language model, right? Because like I said, there's the large language model itself is big that you can't really make them any smaller, but you can make the surrounding stuff much smaller and much faster. You can make it easier to run, right? So instead of having to install a load of PyTorch and the Python stuff, which often conflicts with other parts of your system, and you can now have a very simple command line and only 2 megabytes of compiled application, and you will be able to run the large language model. So so that's it for the demo. That's if you are interested in those in those demos. Again, the WasmEdge URL is GitHub WasmEdge/WasmEdge, and these two demo applications with all the instructions is second-state /llama -utils. Right? That's so if you want to go there and try it out, please do so. Right. So let me switch gears to to go over a couple of slides. I know we only have perhaps 20 minutes left. But I want to tell you why we do it, right? So let me change that. All right.
By the way, folks, I dropped the GitHub link for WasmEdge. If you like, I will definitely say you will love the project. So do star and poke, and if you want to contribute to the project. Yeah.
Yeah. All right. Thanks. Yeah. So so here's a little presentation I prepared. That's it's relevant to what I have shown you. So you have seen how easy it is to use Rust to write application and then to run it in WasmEdge to do the state-of-art AI inference, because the speed you have seen is really the state-of-art. It's the fastest you can get anywhere in the world. That's to run large language models like this, right? So we have a presentation, but why do we do this? I mean, because the question you have to ask is that most people use Python. Why don't you guys use Python? That's the number one question that we get, right? Because as you can see, Python is by far the most popular programming language now. Especially with AI. But precisely, we want to avoid Python in inference because Python is very, very slow. Although for regular inference applications, you don't feel it because Python delegate most of its workloads to the underlying C libraries like PyTorch or TensorFlow and what have you. But if you are not careful, if you do any of the if you start to do anything that's in pure Python, but not in the underlying C library, which is not obvious and not transparent to you, you would be hit with a huge performance penalty. That's Chris Lattner is a very famous person. He's the founder of LLVM. He's the founder of Clang compiler, and he's the inventor of the Swift programming language. He wrote this blog post of a new native language that he invented as a Python competitor. So he said, it's a native language like Rust or C, or in his case Module, is tens of thousands of times faster than Python. Okay, just let that sink in. It's that if you run an inference application and if you are not careful about the underlying C library that Python used, and you inadvertently used Python itself instead of the C library under Python, you would be hit with a performance penalty of 5 orders of magnitude. Okay, so by avoiding Python altogether, we are avoiding this problem. So that's also, Greg Bachman is the president of OpenAI. He made a similar statement. It's the modern machine learning is try to make Python not to be a bottleneck. is to navigate very carefully around Python. To use Python only as an interface, not to use Python to do any kind of actual computing, right? So that's interesting aspect. But it gets worse because Python is not just slow. It has also reached the point where it's so bloated, it's really difficult to install as well. I've tried. So for the simple task that I've shown you, if you want to have a Python-based the inference framework, which is based on PyTorch, and then have a web server that is written in Python with some web framework that is written in Python, like fast API, whatever, what have you, you frequently would run into dependency conflicts, meaning that you can't install both on the same machine. The pip package manager would complain because each of those are several gigabytes of dependencies. They have very complex dependencies. So that makes it, I think, negates a lot of the productivity gains that Python gives to developers. Is that if you can get it installed, it's great. But a lot of times for the things, especially more complex things you want to do, you can't even install Python. So that's where this tweet come from. So Chris Alban is, if you don't know, is a VP of engineering at Wikipedia, right? So he says, what is the right way to install Python? I mean, he's asking that question. Right? So that's the second problem, right? So here we say why it's so difficult and why it's so bloated. If you look at PyTorch, the latest Docker image with all the dependencies is 3 gigabytes, right? So if you have an NVIDIA GPU, you need a whole new image altogether, which is 6 gigabytes. So so you really need to know which machine you are running at, and which and how are you going to manage those dependencies and all that. None of them is obvious to the new developers, especially if you have a resource constrained machine, right? So that's why we all know this guy, right? Elon Musk said on Twitter, that's so someone said the AGI would build in Python with Python. Let that sink in as a negative statement, because I think people feel desperate or feel depressed that Python would be the dominant language of the future. And Elon says, no, it's not. It's going to be Rust, right? So that's why because of the things that we have mentioned, there are so many things that are difficult. But Python has gone a long way in machine learning and AI, but the future is not going to be Python. At least I don't think so. The future, maybe on the training side, Python would still be dominant because training needs a lot of interactions, truly need a lot of packages. But on the inference side, we have seen instead of a multi-gigabytes Python binary, we now have a 2 megabytes WASM binary that is written in Rust that can run much faster than Python and do much better. Then why not, right? Then so on the inference side, I don't necessarily, so that's one of the major use cases for WebAssembly and a project like WasmEdge. is to say on the AI inference side, the future will not be in Python, but in Wasm instead, right? So because of that, there's a lot of zero Python dependency projects. So meaning there's very popular GitHub project on GitHub that's very specifically Python, zero Python. So like llama.cpp. This is one of the C++ based AI inference framework which we build upon on WasmEdge. So when you see the example I show you use WasmEdge to do AI inference, it's underlying it is actually llama.cpp. So this one has, I think it's outdated. It's the GitHub stars is not 26,000. I think it's 44,000. Something like that. So it's written in pure C++. There's no Python dependencies. That's in fact that's the reason why it's so popular. It's because it doesn't have Python, right? So you can see the GitHub star charts. It's obviously it's very popular. The Python-based PyTorch take years to go like this, and then the C++-based inference framework goes like this, right? And then you have zero Python dependency applications. There's another one called llama2.c, which come from OpenAI itself. It's they also think it's wrong or it's unnecessary to use Python to do a llama large language model AI inference. So they have their own C-based library called llama2.c, and you have Whisper C++. Is OpenAI has open source audio language recognition model called Whisper. So it's an AI inference application written in C++, very specifically for that model, right? So that's it's again zero Python dependency. And then Candle is from Hugging Face, and it's also really popular. Well, it's written in Rust, and the idea is also there would be no Python in it. So people would be able to use it to do AI inference that way. So, like I said, Python is just a C framework. We beginner developers think they are written in Python, but in fact, all they do is that they are trying to avoid Python as much as possible. They want to find the Python API that has C underlying libraries. If they make the mistake of written in pure Python AI inference, the application would soon be very slow, and they would have to get a more experienced developer to look at it and fix this those pure Python issues. So most of the Python issues come from the fact that it is in fact just the underlying C library. But if that's the case, then why not use a more proper C framework, for instance Rust, right? And compare to things like Wasm, right? So that's our central argument that we want to make. So here is a slide that we want to show. That's why we want to why WasmEdge. Because after all we are talking about WebAssembly and WasmEdge here. Why are we using it to as especially in the AI cloud-based or edge-based AI scenario? Why are we using it as those replacements? So compared with Python, it is, we have the simplicity, as you can see, it's self-contained binary app. All you need to do is download that Wasm file. You don't need a package manager. You don't need anything that's to install a bunch of stuff that you don't understand and, try to come. And there's no complex dependencies. If you want to run it on the other device, you just copy it to that device, be it Raspberry Pi or a NVIDIA device or, a Mac, whatever, right? It's ready for cloud development because it's already a sandbox format. So, so it can be directly managed by Kubernetes without container, without Docker. It's easy to modify and make changes because the code is already written in Rust. So there's no slow code like Python does. So you can feel confident that when you make changes, the changes can run in native code, in native speed as well. And it's 1,000th of the overall size instead of gigabytes. We're talking about megabytes. It's for compute. It's orders of magnitude faster, right? That's the argument that people have been consistently making. But then why not just compile the C++ code to native? Why do we need to run it in Wasm? Then it's a classic debate of do we need a container or not, right? So if you just want to run on your local machine, then yes, compile to native and then run your native code. But if you want to run it in the cloud, or if you run on some other people's machine, like an IoT device or something like that, you really need a secure container so that it can be isolated from other people's code and to prevent it from crashing the system, right? So in this case, you would need a lightweight container, that's and also portable container. So so WASM is a great use case. Like I said, that's the CNCF survey said, container is here, but WASM is the future, right? That's where that argument comes from. So there's that's the CNCF survey of 2022. It says containers are WASM is the future, and it talks about WASM adoption in the cloud space. So there are a couple things. I know we are up to the end of the hour, but there's a couple other projects that I can show you about using WASM to do AI inference. So for instance, there's this is actually a community contribution. One of the graduate students contributed this project to us, which is the demo example I showed you is to use WasmEdge to do Llama 2 AI inference. So the model is Llama 2, right? But what about other AI models like language recognition, like image recognition, and things like that. So there's a large model library called the MediaPipe. I think Google is the chief promoter of that. So it has some of the most popular models that are used in Google Cloud. So one of our contributors has built a library and instructions to run all of them in WasmEdge, right? So you can download those models from Google, and then you write a simple application. It's typically 10, 20 lines of Rust code, and then you'll be able to use those models on your compile to WASM, and then you will be able to copy it around. The WASM file can be copied to any device, and you will be able to run those models, right? And so here is example. There's as you can see, it's very simple Rust code. You can almost read it like reading English. So it has a model path, the file that points to the model, the image path, the output path, right? So what it does is that reads the model, reads the image, do the inference, and then here's the function, the API function called draw detection, and then print out the result and draw detection. So if you feed it this image and the standard MediaPipe image recognition model, it would generate an image like this and print a result like this, right? So the draw detection takes this result and draw those boxes around it. So it's really, really simple. That's I would also encourage you to to go to that GitHub repository and figure out that's how you can use those. Those are models that in addition to large language models. So yeah, so now we go back to the large language model. So there's many AI frameworks that we support in WasmEdge. Most of them are again community contributions. People, our volunteers in our open source community, and also our university interns that contributed to support for those popular AI frameworks. And we also support commonly used libraries that are common in AI applications, like the OpenCV library for vision and the FFmpeg library for audio and video and things like that. And for the model libraries that we support the Llama 2 models that I've shown you, the MediaPipe models, and I think we have PR it's ready, but it's still in the process of writing documentation and all that. The YOLO 5 models, which is a very nice, a very popular computer vision model. You can give it a stream of videos, it will be able to detect people on it, object on it, and things like that. So yeah, that's really all I have. It's really great to meet you guys, and let me go back to project slides, and so we can conclude there. Okay. All right. Yeah. Thank you. Yeah.
Sure, great. Also, I'm just created a banner actually. If anyone wants to go to the website of WasmEdge, it's wasmedge.org. You can go, or otherwise GitHub is obviously it's a great option to start with. And let me check if there are any questions from audience. Yeah, there's someone asked like if they are new to Rust, like they are very new to Rust, so how they can start contributing. Like many people is asking me like around like, isn't it like WasmEdge is very hard due to the Rust because Rust is more on a memory safety kind of thing. So how anyone can get started with the contribution part in WasmEdge if they want? Yeah.
Yeah, so for contributions, really, there are several easy ways to get started. So I guess if you are interested in contributing to WasmEdge itself, you can go to WasmEdge and then go to the issues. There are lots of issues, and some of them are labeled Hacktoberfest, right? That's you can, they mostly require some Rust or C++ skills. So if you are skilled in C++, that would be a really good place to start. But if you are mostly interested in AI stuff, I would think the depository that I've just shown, here, is a good one. So that's Llama utils, under second state, right? So it has 3 demo applications. It has very detailed instruction in terms of how to install them, how to compile them, and how to use them. And I would really encourage you to maybe the ones that need contribution is really the API server, because the API server is where people use this in production, right? So have different models. So there's, I think, hundreds of models that published for fine-tuned Llama 2. They each have a different chat template and all that. So to integrate them all into the API server is something that I think would have great value. So for instance, if you see a new model that come out that's based on Llama 2, and you can just come in here and add it to the API server, because if you see here, there's a set model. Let me show you. Yeah. So from this command, you give the model file, and then here is the template. So because each model has a different, a way of organizing, delimiting what's the user said and what's the bot said, so that they can differentiate from the conversation, so that they can follow the conversation, right? So go look at the source code, and so if you have a new model, and you can add a new template here and have it running, I think that'd be great. So yeah, so 2 places to contribute. One is the WasmEdge main repository, and the second one is really to get this running, and then to see you can how you can enhance the AI inference experience for the larger community. Yeah.
Also, is it possible, Michael, like if you can share some of the links and the slide links, so that if anyone wants to go through or wants to do something?
Yes, absolutely. So so there's so all those GitHub repositories has very detailed documentation. Let me actually share the links to the GitHub repository in the chat. So this is the API server I mentioned. So it tells you how to run it, but if you want to do here's the demo that I mentioned. It tells you how to run it as well. The demo I showed in the talk. Okay, so yeah, so those are, I think, easy things you can do, and here is the main repository.
Yeah, I guess I shared this thing.
All right. Yeah. Oh, thank you. That's very cool.
And let me share the proper demo also. section. Yep, I can see this. Open the chat. Let's see. Yeah, I guess it's it. And also, if anyone in students or even though someone's graduated, I guess even though I tried 2 times, but I'm not able to get into it. But LFX, like WasmEdge is also into LFX mentorship also. So if anyone wants to be a mentee and wanted to do it, they can obviously start doing it. Even I tried my best, but maybe better candidate goes for that. But yeah, I will definitely try again and again for the same. Because I really love this project actually, because I use in some of my small projects around it. So yeah, this is some of the more option around it. And again, I will drop the Discord link of WasmEdge community in the chat, or you can check in the description box also. We are actually added all the links of WasmEdge and second state communities. All the links are on the description box. You can check it out. And first and foremost, thank you so much, Michael, for accept our invitation and share your learnings around it. We are really appreciate that.
Thank you so much, and wish everyone good luck with your pursuit of open source and and your career in computers. Yeah. So, thank you.
No, because I have a talk with Haidai around the same thing, around open source thing, like we are doing since our when we are in the college, and it's so fascinating to see how open source grow in recent years actually, and people are really appreciating the power of open source right now.
Yeah. I'm glad. Yeah. Thanks.
Because I can see you because you're from J I guess you started from the JBoss community and you've been part of JBoss. And one of my friend actually started his, I guess, journey open source from JBoss, as a GSOC mentee actually. So I see a lot of thing happening through JBoss and JBoss community actually on that front, maybe on the containerization part to that thing. So yeah, we don't know how the whole community goes and get into it in the same place. So, yeah.
Yeah, it's happening all over again. When Java first came out, it's pretty much the same thing. People ask why. Why do you need to compile to Java? That the JVM is very similar to Wasm. If you think about that.
Still people are using it, but I am very optimistic about the WebAssembly as a technology. Maybe it can grow because no one thinks of WASM can get into the containerization part. People think it's just for the thing when you're creating any application or any web page, you can do that on a binary level, but no one can think of it can goes into the containerization part. Maybe WASM can go into many different ways. So. By the way, I really love your talk on the last year WASM.io Barcelona. Even though I'm not there, but I listened through virtually on the YouTube playlist kind of thing, and I really love your talk around it. So yeah, I maybe I will see you again, and I guess again WASM.io is happening. I don't know if you are will be there, but I will love to see your talk again over that place for sure. Yeah.
Really appreciate that, and I do wish to see you in those conferences like KubeCon. Next year's KubeCon is in India, right? That's
yeah, it's in India first time, so we are damn excited about that.
Yes. We'd love to love to be in India for that. That's
Yeah, actually that's our main my main you can say not query if I will say, but why WASM communities or WASM community is not happening in India, any meetups kind of thing. Even I think so I talk about this with I guess with Vivian for the same. Is it not possible? Can you bring second state community or a WASM community here in India and do some meetups kind of thing, kind of that thing? So, by the way, India is in general Indian tech community, people are really interested about the WebAssembly tools, WebAssembly dev tools kind of thing. So we will love to see you on the KubeCon for sure. I guess in the next year maybe, yeah.
Well, really excited. We certainly would try. That's that's we would love to come to India. To engage
sure
our developers.
And thanks folks for joining, and I hope so you got some insights, even though what I will try to do for the whole stream thing. So I will write a blog around each stream that we are doing, or what I do, I accumulate all the resources in one blog of all the stream that we are doing. So it is better for you to, if you want to go for you to understand better how you can get started with it. But Thanks for joining, folks, and I hope you got something from the stream. And I also learned a lot throughout the stream. Some maybe some the question that I asked is one or with you can say one or two is my personal also in some or other way. But yeah, again, thanks, Michael, thanks for sharing your insights, and I hope so. Finger crossed to meet you soon in person for sure. Yeah.
Yes, yes, definitely. Thank you.
Sure. And also, maybe it's not a kind of I will say a marketing kind of thing, but we are also having our organization, and we actually have some open issues for the beginners, those who are totally beginners in coding and in that term. So you can go there, and good first issues are open, and we are kind of for the reference, we are doing a clone of Meetup.com in an open source way. So all things are like, or all issues are beginner friendly. You can start contributing to it, and I will be there to maintain that for sure, obviously. And again, if you like WasmEdge, the second state project in any project or our project, like please do share in the community if you love this project or not. We will. That's what actually community does, I guess. So we will love to have you on other parts soon. So yeah. Okay, till then, I guess thanks, Michael, for joining again, and yeah, see you soon. Yeah,
See you. Yeah, thanks. Bye-bye.
sure, sure. And I'm right now just going you on the backstage so that we can end the stream around that. So yeah. Uh, Again, thanks, folks, for joining. Yeah, tomorrow we'll have another stream with same WASM open source project. I will say Fermion Tech, basically, or if I'm responding correctly, I guess it's Fermion only. So we will see you tomorrow again for the same thing. We will love to share around that thing, and I hope so you love whole the stream. And if you have any queries, any doubt, go to the Discord channel of the WasmEdge community, and also you can go to Discord channel of our OpInCo community also. If you feel that if you have any queries regarding anything I want to introduce in any way, we will love to have you there. And till then, see you, tata, bye bye, and have fun.